probability-wise. And I probably got it wrong.
Yeah, good. Here, the only difference is going to be, see how the top didn't change, and the loser Republican president. The loser
What's because
Democrat.
it depends on the bus, because like, by the time this one leaves and you make the other one leave, so it's like, it's 2 hours and leave my time. See if we buy one.
All right, guys, let's take a look here. I understand that this one was weird. I understand that. We're going to go over that. Hopefully none of the rest of them were too weird. The only time, that the bottom is going to be different than the total number is when I give you information about who it could be. Right? If I don't give you information, who could it be? Any of the total. But like on part E, that's the only place where the bottom is not going to be 176 because I tell you they're a computer science major. So you can throw everybody else out. They don't matter. So let me catch up to you real quick with the, let's see, what's that? 92, 73, 11, oh shit, 126.
Yeah.
Is that right? 50, 176. Ooh, Jeff can add. All right. So the probability they attend Grossmont, that should be nice and easy. Out of 176, because I don't know a damn thing about them. So it could be any of these students. How many attend Grossmont? 126. And that is what, roughly, is it? 0.7? 159? Okay. And you can make that 71.6%, whatever. A lot. Now, I'm glad, I don't think I saw anybody that thought these were related somehow. These are totally different problems, right? So you kind of reset. Let's probably think of business major now. Yeah, 92 chances to get a business major out of 176 people. And then whatever that is.
5227.
5227. Just to warn you guys, if you like round incorrectly on enough problems, I'll take like a point off for that. Just round correctly. Right? Don't just truncate. Don't just chop. Round. Is a computer science major or attends Grossmont. So going into this problem, I know that the top should be bigger than for either one. Or gives me more chances to match what I'm looking for. So one way to do this is to go, there's 120, let's see, there's 73 computer science majors, 126 Grossmont people, but then I got to subtract off. Now watch, and is very often called intersection. And you see why, if I take all these people and all these people, where's the intersection? Here. So those are the people that are both, they got counted twice. I better subtract them off. Hopefully, I think some of you guys did this. Some of you guys did 126 Grossmont students plus 11 computer science majors that I didn't count yet. That's beautiful. Makes me cry a little bit. It's awesome, little tears of joy. If you did this, you're fine. That's actually the formula. This is just being smart about how you count this shit. It's just counting. That's all it is. You should be able to have methods to count very quickly. So you get 137 out of 176? And then whatever that is. 0.77?
84.
84? Okay. I like it. You're the only one, Jeff. Okay. Right here. All right. Now, am I given any information? Do I know anything about the student here? I don't know a thing. It's the probability that they're this and this. So the bottom is still going to be 176. And is restrictive. You have to meet both conditions. How many students are math majors and go to Cuyamaca? 2. And again, and is intersection. Cuyamaca, math, there's the intersection. There's only 2 people that do both out of 176. Are you guys with me? So if you get a large numerator on an AND question, you want to kind of go, am I sure about that? That's a little weird. Or a very small one on an OR question, because OR should increase things and should decrease things. So here's my first given. So I know that they're computer science majors, so how many people total am I talking about? 73. Out of those 73, how many are Grossmont students? 62. And what is that, roughly? 8493? Okay, all right. Now, you guys are all going to totally get this. So I'm going to say to myself, the idea of independence is nowhere near as difficult as people make it. You cannot answer part F with a paragraph of words. You cannot. The idea here isn't that I have to be one before I can be the other. That's not what dependent means. All right? It just means, does one change the chances of the other one? So before I know anything about their major, what's the probability they attend Grossmont, period? 0.715, let's say about 72%, right? Just to make it quick to say, right? Roughly 72% if I round it a lot. If I know that they're a computer science major, does that probability change? And where is that done? I already did the work, part E. That is the probability they're a Grossmont student. That is the probability of Grossmont student, period. Given some more information. So did it change?
Yes.
It went up. So if I know that the student is a computer science major, the probability increases a decent amount. And of course, it's the kind of thing you do with drug trials. What's probably going to die? This. Okay. What's probably going to die once they get this drug? Oh, it went down. Oh, good. Let's start marketing that shit, right? I mean, this is the conditional probability is used everywhere. And like I said, we sort of informally use it all the time, right? And this is actually the one probability that's kind of hardwired into us because it's the one that keeps us alive. Let's see, is it saber-tooth tiger eating time? Yes, I'd rather take this route because that one goes right next to their freaking home. Okay, that means, given that I go this way, I'm going to die less often. Okay, let's do that. All right? So are they independent? Hell no. Because the probability of Grossmont student does not equal the probability of Grossmont given computer science. That is the check for independence. If they're independent, that means that if one thing happens, the other thing should not give a shit. Right? Isn't that what independent means? If you're independent from your parents and they do something, do you care? No, that's the whole point. If you still live in their roof and they decide to knock your wall down in your room, that's going to affect you. You're sort of dependent on the weird shit they do. Are you with me? So dependent means the same thing in statistics. If these were equal, that means that this guy didn't care that he happened. But does he, in this case? Yeah, the numbers. So you need to see the numbers. Because I'm a math guy. So 0.7159 does not equal 0.8493. They are dependent. Poor little dude. So do not say, well, no, you don't have to be a computer science major to go to Grossmont. That's not the idea anywhere near it. That's not what dependent means. It's talking about, does it affect the probability of that happening? I like it. What time is it? It's getting close. Just do these real quick and then we'll head out. The first two here I'm going to do very quick because they were simple. 7 Democrats out of how many total people? All right, that's 1/3, blah, blah, blah. Republican would be 12 people out of 21, right? That's 4 sevenths, blah, blah, whatever. Make that into a decimal, a percentage, whatever you like. Okay, those are nice and easy. I just want to get things kind of started on this one. With replacement, the first one's independent would be 2 out of 21. And then, so times Republican, 12 out of 20. I didn't lose anybody. So whatever the hell that comes out to be. You got to tell me this, but this is what's really important, is this. What does it come out to be? 0.0544? Maybe? Okay. 2 Democrats. And that's always a hidden and. That's another way to say we select 2 Democrats. We select a Democrat and then another Democrat. So you can kind of reformat it to be the same. So the first guy's a Democrat, 7 out of 21. Second one's a Democrat, 7 out of 21 again. Nothing changes because it's with replacement. So that'll be 1/9, it'd be 11.111%. Right? 0.1111111. Now look here. This is gonna. I always do this. I ask the same damn question, but now it's without replacement. So the first dude is the same. But now what happens on the second probability? I still have how many Republicans? 12. But I lost a person. I let one person leave the haunted house, right? And then whatever the hell that is. 0571? I like it. And now this one, of course, 7 out of 21, I let that Democrat leave. So now I've got 6 Democrats out of 20 people. And what's that become? Point 1, is it? All right, I'll sounds right. Yes, it is. I like it. All right, so now, next time we'll do this number 3. There's a little bit more I got to talk about for number 3. In the back, you can do whatever you like. I'm going to give that answer key out so you can have it for study for the quiz.
Next week. Is that way it goes like,